Give the exact value of the definite integral from 1/2 to root 3 over 2 of 1 over the square root of 1 minus x squared dx. Now the first thing we ought to do is get a hold of the indefinite integral, and we'll prep it. So we're going to have the indefinite integral of the expression 1 minus x squared to the minus 1/2 dx. And the antiderivative of this is simply the arcsine function. Now that we've got an antiderivative, we can handle the definite integral to integrate from 1/2 to root 3 over 2 of 1 minus x squared to the minus 1/2 dx. We simply need to take the arcsine function, one of the antiderivatives, and evaluate that from 1/2 to root 3 over 2. So if we plug in root 3 over 2 first, we'll have the arcsine of root 3 over 2, and we'll subtract from that the arcsine of 1/2. Now we just have to work out these two values right here. Focusing on this value, the arcsine of root 3 over 2 is an angle. It's the angle theta, where the sine of theta is equal to root 3 over 2. And since it's positive, this is an angle in quadrant 1. So if we draw a reference triangle here, the opposite side is a root 3, the hypotenuse is a 2, the missing side is a 1 by the Pythagorean theorem, and so we're looking at a 60-degree angle. And so that means the arcsine of root 3 over 2 is pi over 3. Now let's focus on the other bit. Doing the same trickery, the arcsine of 1/2 is the angle theta, such that sine of theta is 1/2, and theta should be in quadrant 1. So if we draw a reference triangle and label the opposite side 1, a hypotenuse of 2, the same rigmarole, we have a 30-degree angle. So the arcsine of 1/2 is pi over 6. And so our definite integral is equal to pi over 3 minus pi over 6. And that's 2 pi over 6 minus pi over 6, or pi over 6. And so there's our definite integral.